We're going to be taking a look at graphing inequalities. Now, the main difference between inequalities and what we did last unit in Unit 1, where we solved the equations, is the symbol between the two mathematical expressions. And that symbol now is going to be an inequality symbol. Most likely you're already familiar with the four inequality symbols. We have the is less than symbol, the is greater than, is less than or equal to, and is greater than or equal to. So you're probably familiar with those four symbols and those top four expressions. Now there's other ways to translate the English into that mathematical symbol. Another way for is less than is you could also say it is fewer than. And another way to say is greater than, you could say it as is more than. Alright, now there's a couple of ways to translate the is less than or equal to symbol. You could also write it as is at most. And then the second way to say that is no more than. Alright, then there's two ways to also say is greater than or equal to. You could write that as is at least. And finally, you could write it as is no less than. Alright, so keep these phrases in mind here as we translate between the English and the math. Example 1 asks us to write these inequalities from the sentences that were given. So letter A, the number of people at a soccer game is over 1,000. That means n, our variable for number of people at the soccer game, has to be greater than 1,000. And letter B, we have in order for someone to be eligible to vote, they must be at least 18 years old. So you can see here, is at least is a part of the phrase for greater than or equal to. So we'll say age, A, has to be greater than or equal to 18. In expression, or in letter C here, we see a number C plus 9 more is greater than or equal to -6. So we have the variable C plus 9 more is greater than or equal to -6. And in letter D, we got 10 is no more than the sum of 3 times a number y and 9. So is no more than, you can see, is an expression for the less than or equal to. Alright, so we'll write that as 10 is less than or equal to the sum, which is addition, 3 times the number y and 4. Alright, in example 2, we are going to check to see if a particular number is a part of the solution set. Now, if it's a part of the solution set, it will make a true statement when we substitute it in to the inequality. So let's determine if 4 is a solution to the inequality 2x minus 10 is greater than or equal to 6. So that gives me 8 minus 10, which is -2. Greater than or equal to 6? No, that's false. And because it's a false statement, we know that 4 is not a solution to this inequality. Alright, let's do the same thing for example 2b. We've got 1/2 our x value plus 4 more. Is that less than 16? So 1/2, 4 is 2, 2 plus 4 is 6. Is 6 less than 16? Yes. So we'd say yes, 4 is a solution to this inequality statement. Alright, moving on to the second page of our notes for section 2.1. We're going to talk about graphing inequality solutions. Now, you've probably done this before, and just a quick little reminder, there are two types of circles that we use. An open circle is used to signify that a number is not included as a part of that solution. And we're going to use those for when we graph those less than or greater than symbols or inequalities. The other type of circle that we use is a closed circle, and we're going to use that when we graph and the number is a part of the solution. Alright, so those are going to be used for graphing the inequalities of less than or equal to or greater than or equal to. All right, let's do a few examples, and I think you'll see what we mean here. We're going to graph this basic inequality of all x values that are greater than -5. So we're going to start off by numbering our number line, including several other values. And we're going to start off, we got a greater than, so this indicates that we're going to use an open circle at -5, and we want all the values that are greater than -5. So that's to the right of -5. And we will shade in our arrow indicating that this solution set continues on infinitely. So any of these values that fall in this shaded arrow will be a solution to this inequality. For example, -3 is greater than -5. 0 is greater than -5. All right, let's try this next one, example 3b. We want all the x values that are less than or equal to +9. All right, so once again, we'll start off by numbering our number line. Let's say we have 6, 7, 8, 9, 10, 11, and 12. All right, we want all the x values less than or equal to. We have a less than or equal to. That means we are going to shade in our circle at 9, and we want all the values that are less than that 9. So that's to the left of 9. And again, we'll shade in that arrow and indicating anything to the left of and including 9 will make this a true statement. All right, in example 4, we're just going the other way now. We are asked to write the inequality that is graphed below. So let's take a look at our number line. It looks like we have a closed circle here at 2. That indicates, I'm sorry, that's a closed circle at -2, indicating that -2 is a part of the solution. And then we want an arrow to the left of that. So let's just say this is our x number line here. This would be the inequality of all x's less than or equal to -2. Now, that's if we write the variable on the left. We could also write our number on the left. -2 is greater than or equal to x. These two inequalities represent the same thing, and we can see that they're both true. This is also all x's less than or equal to -2. All right, let's talk about interpreting an inequality. Example 5 says, let A represent the number of students in the freshman class, and B represent the number of students in the sophomore class. It is known that A, the freshman student number, is less than B, the sophomore student count. All right, determine if the following statements are true. Well, part A says, interpret the meaning of this inequality. What does it mean that we add A plus B and have it be less than 2 times B? Well, it means the number of freshmen plus the number of sophomores has to be less than twice the number of sophomores. All right, so let's think about this now. We know that the number of freshmen is less than the number of sophomores. So let's just make up some small numbers here. Let's say there's 20 freshmen and there's 21 sophomores. So 20 plus 21 has to be less than 2 times 21. Is that a true statement? Yeah, that's going to give us 41. Has to be less than 42. So this is a true statement as long as our number of freshmen is less than the number of sophomores. All right, let's check our next one here. Interpret the meaning of the inequality. A over B has to be greater than B over A. So this is the number of freshmen over the number of sophomores has to be greater than the number of sophomores divided by the number of freshmen. Again, if we were going to use the same numbers that we came up with up here at the top, what you would have is 20 over 21 has to be greater than 21 over 20. Now, another way to think about this is that this first quotient here, this first fraction, is a smaller number divided by a larger number. So this number here is actually going to be less than 1. Whereas the second number, if we take the reciprocal of that second fraction, 21 over 20, is going to be greater than 1. So your statement is a number less than 1 is greater than a number greater than 1. Well, that is a false statement. All right, that's all for today. We'll see you tomorrow.